When mountains, rivers, or busy cities stand in the way of progress, engineers don't stop. They build tunnels, and to carve those massive tunnels through rock, soil, and sometimes even under oceans, they use one of the most powerful and fascinating machines on Earth, the tunnel. Boring machine, or TBM. This is the true story of how tunnel boring machines work, the hidden giants that shaped the modern world underground. Remember to like and subscribe for more fascinating insights. What is a tunnel boring machine, TBM? A tunnel boring machine is a huge cylindrical machine designed to excavate tunnels through a variety of ground conditions, from soft clay to hard granite. A TBM can be as long as 100 meters, almost the length of a football field. The largest TBMs have cutting heads over 17 meters in diameter, big enough for multiple highway lanes. Fun fact, TBMs are so big and complex that some people call them underground factories. So, parts of a tunnel boring machine. A TBM is made up of several key parts. Cutterhead, the rotating front end with cutting tools that break through rock or soil. Shield, a protective outer shell that supports the tunnel walls and prevents collapses as the machine moves forward. Thrust system hydraulic jacks that push the cutterhead into the ground, applying incredible pressure. Conveyor system, a belt or rail system that carries away the excavated material called muck. Segment erector, a robotic arm that installs concrete tunnel lining segments to form the new tunnel walls. Backup gantries support cars that trail behind the TBM, carrying equipment like ventilation, electrical systems, and more. How does a tunnel boring machine work? Well, let's go through it step by step. Here's how a TBM bores a tunnel. First, positioning. The TBM is assembled at the tunnel's entrance or inside a specially dug launch shaft. Next, cutting. The cutterhead rotates and grinds away rock or soil at the front. Then, muck removal. The broken material is collected and moved away by the conveyor belt system or rail carts. After that, advancing. Powerful hydraulic jacks push the TBM forward against the tunnel walls. Lining the tunnel, as the TBM moves forward, the segment erector places precast concrete segments to form a strong, watertight tunnel lining, and finally, repeating. The TBM continues cutting, pushing, removing debris, and building the tunnel until it reaches its destination. Different types of TBMs. Depending on the ground type, engineers choose different kinds of TBMs. Earth pressure balanced TBMs are ideal for soft ground. They control pressure at the face to prevent collapses. Slurry TBMs use a special fluid or slurry to balance pressure in very wet or unstable soils. Hard rock TBMs are equipped with heavy-duty disc cutters to chip away at solid rock. But challenges TBMs face, even the most advanced TBMs face difficulties. Unexpected ground conditions like pockets of water or gas, wear and tear on the cutterhead tools, navigation issues to keep the tunnel on the right path, and the logistics of getting rid of thousands of tons of excavated material. Famous TBM projects. Some of the world's most famous tunnels were built with TBMs. The Channel Tunnel between the UK and France, where TBMs worked from both England and France, meeting precisely under the English Channel. The Gotthard base tunnel in Switzerland, created with massive TBMs to tunnel under the Alps. The Big Dig in Boston, USA, a huge highway project beneath downtown Boston using TBMs. Each project pushed TBM technology to new limits, building longer, deeper, and safer tunnels than ever before. In conclusion, tunnel boring machines are true giants of engineering, blending raw power, precise technology, and incredible teamwork. They transform impassable obstacles into easy pathways, allowing cities, highways, and railroads to grow and connect across mountains, rivers, and oceans. So every time you pass through a tunnel, remember the silent, powerful machine that dug it. A TBM carving its way beneath the earth 1 meter at a time. TBMs show that no obstacle is too great when humans have the imagination, technology, and will to dig deeper.